We are talking about measuring the spread of disease now. Okay, so here are our 2 dot points, and we're still in chapter 9.1 of Pearson. All right, so the Centre of Disease Control in various countries and the World Health Organization measure spread of disease, and they need to monitor global health. So we can talk about disease outbreaks, and disease outbreaks can be considered endemic, epidemics, or pandemics, right? Now, if we look firstly at endemic, the word endemic means that there's a baseline level of disease in a community, and outbreaks can occur in regions, but the number of cases remains pretty steady. If you're talking about a disease being, part of an epidemic, we're talking about an increase in cases. It's often sudden, and in the number of cases above what is normally expected in that area. If we're talking about a pandemic, it's suddenly just an epidemic that has spread over several countries or continents and usually affects a much larger number of people. We understand that one. Now, R0 is a reproduction number, and it measures how many new infections will arise from one primary case. We need to use this as a way to estimate how many people are going to get sick, essentially, and the number of secondary infections that a primary infection will produce is our, talking about our R0 number. So we need to be able to keep track of who's going to get sick, how many people are going to get sick. And in this case, it's usually where a disease is not endemic. So when no one is, vaccinated against this, it is, essentially the entire community is vulnerable. Now, obviously, some are more contagious than others, so the R0 number is going to be very, very different. If you look at measles, very high R0 number, whereas if you look at, say, something like Ebola, which is extremely deadly, it doesn't really have a very high R0 number, so it's not very contagious. Now, if we have an R0 number that is over 1, it means that the transmission is increasing, outbreaks are possible. However, if it's stable around 1, transmission is stable as well. If the R0 value is less than 1, then transmission is decreasing and the disease is kind of going into local extinction. So for example, if you have an R0 of 2, it means approximately 2 people become infected from coming into contact with one diseased person, right? And this isn't a hugely contagious disease, but it's not great either, right? So for every 1 infected new person, 2 new people will become infected, right? And if you're talking about an R0 number of 7, you're going to have a big, ugly tree diagram if you just let that person out into the community. There are some really interesting ways that diseases can be transmitted, and the way they track them is also really fascinating. So if you look at this weird chain of transmission one, it's just passing from one person to the next, but obviously we know that things are a lot more complicated than that. And yes, if, say, we had an R0 number of 2 and you go out into the community, you're not necessarily always going to do pass that infection onto 2 people. You might pass it on to more, you might pass it on to fewer. And if you don't go out into the community and you stop that spread, then obviously the tree starts to become a little different looking. Now, R0 numbers are published for different diseases and they can be hugely variable, and they're average because R0s are so contextual and location specific. So if you're talking about even COVID-19, even between different states, you have different R0 values at a different time. So R0 values for some really common diseases there, you can see them in Pearson. If you put them in a diagram like this, you can see measles is really, really high up again, and there's that Ebola really far down. So here we go. We have H1N1, but we also have H5N1, and they're all the same disease in different locations, and you can see a hugely variable number there. So between, hey, there's nothing going on in our community, it's still really small, to, oh my gosh, the infections are increasing. Now, we need to be really careful because infectivity, or how contagious something is not the same as virulence, okay? Pathogens can be extremely virulent, but not highly contagious. So we talked about Ebola before. We know that that one is a very deadly virulent disease, but it's not a contagious one. So pathogen persistence and how persistent that pathogen is in the community, it will influence the spread of the disease in terms of how long it also stays in the host, stays dormant, shows symptoms, all those kinds of things. But there's always these lovely charts about how contagious a disease is versus how deadly it is. So, you're talking mumps over here, very contagious, not as deadly as, say, rabies up here, which is very, very low in its contagion, but very, very deadly. Now, there's lots of different ways to reduce spread of a disease in the community, and methods are going to depend on the mode of transmission, obviously. So we can always talk about community and personal hygiene and behaviour. So we might be talking about, medical care, disinfectants, personal hygiene, washing your hands, how, are we cleaning down the parks? Are we washing down the trains? What are we doing? Are we spraying for pesticides for our vectors? Are we immunising the community? And all of that behaviour and all those things are going to very much influence whether this, say, R0 of 3 is actually going to keep going. If this person doesn't, go to work, they're not going to run into this person, and the spread can be contained. Also really important to think about the community services available. It's one thing to go, oh, well, you're not washing your hands well enough. It also might be, I don't have time to leave work to get myself a COVID test because I can't lose that income. So, are there any doctors available? Is the line to get a COVID test really, really long? We have to consider those types of things as well in our communities. We obviously like to reduce the spread by talking about herd immunity. We know that vaccines are safe, efficient and effective, and a critical number of people need to keep a population safe from re-emerging diseases, and that number is going to depend on the pathogen, the mode of transmission, the number of vulnerable individuals and things like that. If we do have herd immunity in the community, the presentations of disease are actually less severe. And immunisation coverage has a huge impact on this. And we have immunisation thresholds, and it's going to depend on what disease it is. For example, if we talk about, say, smallpox, we need 80 to 85% of the community to be vaccinated. Probably not as relevant to us, but if you look at the measles one, 83 to 94, that's quite a high threshold. We take a look at mumps in the, Pearson's got some lovely little pictures as well. Okay, if we look at mumps, this is an example of mumps in the Netherlands. And if the R0, say in this case for mumps, the R0 is 4 to 7. So that's quite high. And the vaccination coverage was 75 to 86%. So if we look down here at vaccination coverage at 10 different schools, we can see, if I said 75 to 86%, if we stop about here and we look then at the cases, overall attack rate is really high versus really, really low when that vaccination coverage is really high. So if an R0 is high and vaccination coverage is below the agreed upon threshold, then outbreaks can occur. It's that simple, right? If there's no other strategies used to reduce transmission and we're just looking at herd immunity and vaccination rate, that's the thing we need to think about in terms of outbreaks occurring. All right, there are our dot points. Make sure you have a review.